Welcome. This video provides an overview of processing arrays. Pretty much anytime you're working with an array and you want to do something to it, you want to do that to each element, or you want to search all the elements for a particular value. Anytime you want to do that, you need to have a loop. So our basic recipe for working with an array, for going through each element, is always going to be some kind of loop. For loop, while loop, doesn't really matter. But assuming we want to start at the beginning and go to the end, we'd want to start counting from 0, because that's the first element. We want to go up to size minus 1. So if we do I equals 0, I is less than array size. Then for a size of 5, we'll go 0, 1, 2, 3, 4, which is what we want, because those will be the 5 elements. And we'll count by 1. And if we wanted to do every other element, we could count by 2. If we wanted to count down, we could start with the size minus 1, keep going until we hit 0, and reducing our counter I each time. But however we set up our loop, inside the loop, we've got two things that we can talk about. I, the current index, what position we're at, 0, 1, 2, 3, 4, and the array sub I, the current element. Basically, anytime you want to say the current thing, as you're going through, looping through an array, you say the array name sub I, assuming I is your counter, which is kind of standard practice. So I got that same code here in Qt Creator. I'm going to put a breakpoint in and build this up, and now I'm going to debug it. And we get to this first line, and I can see that I is 0. I can see my whole array, and so I can kind of do the math and say, okay, well, if I is 0, then num sub 0 is 10. And so this first one better print out 10. Okay, go ahead and let it step through this line. I'm actually going to tell it to go ahead and go until it hits the breakpoint again. And it's so great, it prints out element 0 is 10. So we can always kind of look at this. If you actually want to see what the current element is, you can add your own expressions to the debugger. If I right click and say insert new expression evaluator, I can type in num sub I, and now it's always going to show me what the current value is. All right, I can see that I is 1, so num sub 1 is 12, or I can just look at my evaluator that I added that represents the current thing. All right, so now we're going to print out the 12. There it is. Now we're going to print out the 16. But so you can use the debugger to keep an eye on the current thing. Let's look at some more recipes. Say I want to initialize all the values to 10, and I don't want to have to type it. Wouldn't be too bad with 5 things, but maybe this array is 5,000 elements, and I don't want to type 5,000 tens. I can loop through the array and set the current element to be 10. I want to copy from one array to this other array called other nums. So I have to make my second array, loop through from 0 to the end, take the current value from nums, and copy it into the current location in other nums. And I'll have 2 copies of the same data. If I want to total up an array, so I've got an array of doubles here, I need to have some variable and keep track of the total in, and I better initialize that to 0, or it's going to start with a random value, which could and will produce unpredictable weird results. And then I've got to loop through all the values in the array, get the current value, value sub I, and add that to the total. After I'm done going through everything, I know the total. If I want to find the smallest thing, well, I can assume that the first thing is the smallest. So grab values sub 0. That's the first thing. So I'll assume that's the smallest. And then start from item at index 1, so the second thing, going into the end. If the current value is smaller than the smallest thing, then change the smallest thing to be the current thing. So we'd have 1.4, we check against 5.2, and then 3.6, and if we ever find anything smaller, we'll change the lowest, and when we're done with a loop, that will contain the smallest value. sometimes we want to talk about neighboring things. So if I want to check and see if this array is sorted, if it is in ascending order from smallest to largest, one possible way to do that is this algorithm. So I'm going to assume it's sorted. I'm going to just take a guess and say, yeah, everything's good. And now I'm going to compare neighboring elements. If I ever find something where the one on the right is smaller than the one on the left, or the one on the left is larger than the one on the right, then I know I've got a problem and it's not really sorted. So I'm going to count from the beginning to the end and compare the current thing with the next thing. Right? If array sub I is the current one, then I plus 1 would be the next thing. So I compare 0 versus 1, decide, okay, that looks okay. 1 versus 2 looks okay. Keep going until I find something like this where, oh, we've got a problem. This must not be sorted. Now, if I don't find a problem, I need to stop, and I need to stop a little bit sooner than normal. I never actually want to check this one. Right? The last pair I should check would be 7 and 8. And if they look okay, then I know I'm in good shape. And I never want to consider 8 to be the current one, because then I'll compare it with 9, and who knows what's stored over there where quote-unquote 9 is. So for this loop, we'd want to go from 0 to size minus 2. Right? Normally if there's 9 things in this array, we'd go from 0 to 8. Here, we want to go from 0 to 7 and have 7 be the last thing. So what this might look like would be, we'll assume sorted is true. We'll count from 0 to less than the size minus 1, which is another way of saying our last thing is going to be 2 less than the size of the array. Check and see if the current thing is bigger than the next thing, I plus 1. If so, then we can mark sorted as false. We found a problem, and we can break out of the loop. There's no point in going on because we know it's not sorted. If we get all the way through the array without ever changing sorted to false, then we'll know that it must have actually been sorted. Otherwise, we'll know that there was a problem.